Hello, everyone. This is Barbara Humpton, CEO of Siemens USA, and thanks for listening to The Optimistic Outlook. One of the ways we've defined optimism on this podcast is this idea of looking at challenges head on, then believing in our ability to find solutions. Take one of the key things we have to figure out in order to build a more sustainable future, which is building an American battery industry to support the electrification of mobility. Over the next 7 years, global battery capacity will need to increase 7-fold in order to meet demand for EVs. Now, doesn't that sound a bit daunting? Rapidly scaling gigafactories and building out a robust domestic supply chain of machine builders? Well, with yesterday's tools, it would have been impossible. But with the technology we possess today, we can do it. And in this episode, you're going to hear me explain how, as I share with you a talk I gave recently in Detroit at the Automate conference. This event brought together thousands of leaders in manufacturing to focus on the technology shaping a new era for American manufacturing. And hey, quick preview, get ready to reframe again how you view industrial automation. Because, it used to be the fear that robots were coming for our jobs. Well, today, this myth is pretty well busted. So what we really need to think about now is why it's actually essential for our manufacturing workers to use robotics in their factories. And not just automation, but software and edge technologies that enable us to optimize how this automation works. We have an aging population, and with it, a big wave of retirees in manufacturing. We're still working on attracting a new generation of people to join the industry. Meanwhile, we've consistently had more than 800,000 open manufacturing roles nationally for quite some time. Even with perfect recruiting efforts, it'll be difficult to fully close this gap. So why do we need industrial automation? We need it to enable the same size workforce to do more. It's part of the solution to how we build that sustainable future. I got to give the morning keynote on day 3 of the Automate conference, and you're going to hear me joking a bit at the beginning about taking the stage the day after Michigan State University basketball coach Tom Izzo. Take a listen. Thank you, Dana, and thank you, Automate. It's so great to see all of you. And I have to tell you that when the first promotional materials went up on social media announcing Automate this year, my son-in-law wrote to me and said, "Grandma Barb, your picture is up there next to Tom Izzo." So Automate, thank you for making me famous. And listen, I want to say, I know you had Tom here yesterday. Was that fantastic? I heard he was crowd surfing at the end. And I know that I'm going to need to transition things, from the Final Four to the factory floor, like how I did that. But basketball really has been on my mind recently. I had the chance at the Economic Club of Washington to interview Tamika Tremaglio. You may know her as the head of the National Basketball Players Association. And we had a chance to talk about leadership a little bit. And her messages actually worked really well with what I heard from Coach Izzo yesterday. This idea that we want to win. We want to win. Whether we're in automation or whether we're coaches, we want to bring passion and energy to the jobs that we do. We want to take the game up a level. And it made me realize that I know what it's like to work with a winning team. Now, you know that winning a season is hard. What about winning a decade or a couple of decades? What about winning a century? Well, Siemens has been winning in automation for over 175 years. And I want to tell you a little bit about us. Listen, 65 years ago, Siemens introduced its first automation system. The automation system is the backbone of modern manufacturing, and today, Siemens is #1 in industrial automation globally. 1 in every 3 machines is actually controlled by Siemens technology. And the innovation doesn't stop with the introduction of the controller. Think about where we've come from. We've gone from repair and replace to predict and prevent. We've given you the ability to create things more efficiently and more securely. And recently, we've introduced the first virtual controller. I'll come back to that because it's an important point. But I'll tell you, about 50 years after introducing that first automation control system, Siemens actually shifted its focus to software. Now, we were already a company known as an engineering powerhouse. We were known worldwide for our manufacturing capability and the technology we're bringing to the table. But we wanted to be known for software as well. But more than just bringing software into our portfolio, what we wanted to do was realize a strategy that today forms our business strategy and can be summed up in one statement. We combine the real and the digital worlds. And think about what software has done for us. We're now able to introduce the new tools of augmented intelligence. We're working on the cloud, at the edge. Now we're able to bring the worlds of IT and OT together. And we're #1 in industrial software worldwide. The best proof point while we're here in Detroit is the fact that the top 22 automakers use Siemens software to produce their products. And we're very, very proud of that fact. But you know what? In this day and age, it's not so much what we do as Siemens, it's what we can do together that matters. And so what I want to do is rewind the clock for just a moment and get us to think about a little bit of history. I'm going back to the year 2011, the year that Mark Andreessen famously said, "Software is eating the world." At Hannover Messe in Hanover, Germany, there were a lot of things being shown. Amidst all the shows, amidst all the speeches, there was a paper that was produced. And it introduced the concept of Industry 4.0. 4.0 as in the fourth industrial revolution. We've all been talking about it. Steam to electrification to automation, and now this promise of digitalization. The promise that the tools that had been rampant in our personal lives already for decades, the digital tools that connected our entertainment and our shopping, connected our communications, all of that could come into the industrial environment. And it sounded pretty cool, right? But it also sounded kind of complex. In fact, as you were being introduced to this topic, if you were like me, by the way, that was my first year at Siemens. I joined in 2011, and I remember the presentations, the TED Talks, the books, people getting psyched about Industry 4.0, and I saw a lot of charts like this one. Remember this? You take a standard manufacturing environment and you put some digital pictures on top of it, maybe some swirly dots that represent electrons, and you say, voila, Industry 4.0, right? And everybody goes, oh yeah, I remember that presentation. There was a chart earlier in the presentation that showed a horse and cart coming down a factory line, and then it would have the tagline, "This isn't your grandpa's factory anymore," right? This was getting us ready for what could come. But the thing about Industry 4.0 was that it really felt like a dream back in 2011. What was it going to take in order for us to get here? Well, it turns out we have all the tools now. Fast forward to today, and what you're discovering is that the tools of both the hardware, the software, and the connection of the two are available to us. And we now have the ability to transform market segments. Some of the earliest ones for us, where we saw this taking hold, automotive, as well as aerospace and food and beverage. And what we've seen is a curve of activity in each case. You start by just collecting data. Let's put sensors in our operations. Let's see what data we have. Then the second stage is, ooh, now that we've got that data, we've actually got feedback loops that let us improve our performance. Oh, well, wait, once we've done that, shouldn't we start to ask ourselves, can we do things differently? And ultimately, that leads to new business models. This transformation is happening in market segments everywhere we look. And what I want to focus in on as a great example of this at play is the battery market. Everything we've learned, the confidence that we've built by seeing these practices pay off is now being brought into the battery market as transportation is converted. Now, imagine yourself, you're a young company, 5 years old, and you're getting ready to take on the awesome challenge of entering the electric vehicle battery market. You know that there are huge problems to be solved. I mean, frankly, we've already seen the data that says in the next 7 years, in order to meet these challenges of transformation of the automotive sector, we're going to need to increase production 7-fold. And by the way, this company wants to produce 200 gigawatt hours of capacity in their new gigafactories. So what have they tried to do? This is Freyr. And what they're doing is working with Siemens to bring the tools of Industry 4.0 to the table. Now, I want to take a moment and let's talk about what are the challenges that they're facing. I mean, the battery market isn't brand new, right? It's been around. It's a fairly mature market. There are processes in place today. It's semi-automated, though you might say, hey, not all the data is connected and flows the way it should. But they've got mighty challenges to work on. Let's think about what's needed in battery production itself. We've got to increase capacity, as I said, but we also find that the market as it exists today has a lot of scrap. And we all know that there are rare minerals that are needed in the production of batteries, so we've got to make great use of those resources. Now, what about the cars themselves? If we really are going to drive that transformation, we know that people aren't going to buy electric vehicles unless they're affordable, and if we can get over that range anxiety problem. So we've got to solve the problem of how the battery performs and what it costs to make. And then coming to the battery production itself, you know, what you realize is that we really need to be more efficient. We've got to create batteries that are lighter weight so they fit in with the final vehicle. They make the vehicle itself lighter and more energy efficient. Overall, if you look at this, this is a challenging space that has all of the elements that you would think of thinking about the use of resources, the sustainability of the process, as well as the transformative effects that we're trying to achieve. Well, Freyr has embraced the tools of Industry 4.0, as I say, and here's how they're approaching the problem. First, let's use a digital twin. Let's make a digital twin of the product itself. And in that digital twin, before we ever put elements together, we can play around with the chemistry, with the physics, with the electronics that are going to house the finished battery. When we're confident that we know the battery we want to produce, or maybe even while we're figuring out the design, let's also make a digital twin of the factory where the batteries are going to be produced. Because, by the way, design for manufacturability is a great thing. And before we start breaking ground and putting manufacturing lines together, why don't we model it and make sure that we understand how the various pieces are going to flow together? Ultimately, all of this leads to a feedback loop that will enable them to take the actual performance of the product after it's produced and feed that back into not only the design of the product as it evolves, but the future process that's going to be used for it. This is fabulous. This is fabulous. And it brings us to this question mark of, whoa, did Barbara just tell us that robots are coming to take over our jobs? And the answer to that is no. Nothing could be further from the truth. Listen, from the first time a human picked up a rock and used it as a tool, tools have elevated the role of humans. Tools have helped expand what's humanly possible. And right now, we're going to need it. Because have you noticed? We've got an aging population all around the world. People are actually retiring out of this field that we love so much. And at any given time, if you look at the data, you see that there are something like 800,000 openings in manufacturing. The only way we're going to be able to address the challenges facing us today and do what needs to be done is if we can make every single person more productive. Now, actually, give this a moment's thought. What happens if every one of us becomes more productive? I'm going to say it this way. The labor factor in all of our business cases becomes minimized. Now, I'm not saying we're minimizing people, not at all, not at all. But if we think about what's happened over the last couple of decades with globalization, jobs have been leaving the US in search of the lower cost labor workforce. We've been doing labor arbitrage, and it's been refactoring where we actually make things. And people call this globalization. And globalization has been a trend, it's a mega trend we've been following for a long time. But you know what? The pandemic kind of changed the picture. And I don't know how much it changed your businesses, but it certainly changed ours at Siemens. Suddenly we had to stop and think about, gee, that single source of supply at the lowest possible cost, when that was disrupted, it had a ripple effect across everything. I mean, think about our semiconductors and how that turned our world upside down. We know that the world now needs to establish more global, regionally distributed supply chains. We know that that's going to be the more resilient answer for the future. And here's the really great news. Once we can make people everywhere more productive, it's not a question of where do we go for low-cost labor. Now the question is about where's our most secure source of energy? How can I get as close as possible to the people who need my product? How can I reduce my logistics so I can be faster and cheaper and actually get things to people when they need it? This whole idea of glocalization, as we're talking about it now, doesn't mean that we're abandoning globalization, not at all. Not at all, because what we are now able to do is recognize that developers, inventors, creators anywhere can now have their products made everywhere. And the question we need to ask for the future is, how do we move data, not stuff? What's fascinating about this time is that it's all been brought about by disruption. And this is the basic premise of my podcast, The Optimistic Outlook. I really hope you'll subscribe, because it's times of disruption that give us the best opportunity to shape the future. Think about it. It's times of disruption when everything ungels and people rethink, what is it that we need to do going forward? And they're willing to accept new and different answers. Let's put ourselves to work bringing the technologies that we've been inventing to the table so that we can change the world. One of the things I'm most excited about is the rise of platforms. You're probably sitting there thinking, hey, Barb, you're talking about Fryer battery, the fact that they're going to introduce a battery that is 3 times higher performance than the original at 90% less cycle time. Yeah, that's great for the greenfield application. What about the brownfield? What about the small and medium enterprises that need to basically be brought along? Well, I actually think we're at a time when one of the most exciting new technologies, the platform, is going to be the answer to that. Platform, what is that? What's the platform economy? Think of the platforms we work with today. My favorite, of course, is the iPhone App Store. What the iPhone App Store does is it gives us the opportunity to access tools. And frankly, it gives us the opportunity to publish tools onto it. In essence, a platform allows us to work as an ecosystem to create value. And what you find with a platform is that the more value you create, the more users are drawn to your platform, which in fact creates more value, which leads to more innovation. And pretty soon you've got the flywheel running. And if you've read Good to Great, you've seen the concept of the flywheel. Right now, the idea of the platform is coming to our world. In the past, people had thought that manufacturing is going to move at a relatively slow speed. There's no way that these concepts apply to where we are. And the fact is, the platform economy does work. In fact, this is why Siemens has introduced our open digital business platform called Siemens Accelerator. What Siemens Accelerator allows us to do is bring our portfolio of hardware and software online, make it accessible to users, and then allow an ecosystem of partners to, through open APIs, to enhance and build and create greater value that then is available to others. Now, by the way, Industrial Operations X is an offering on the Siemens Accelerator platform today. What does it do? It's bringing together our hardware, connected devices, into an environment with our software and our services, and offering that up as a service. Now think about it if you're a small or a medium enterprise and you don't have the CapEx, you don't have the IT departments that some of these large enterprises have. Here is your opportunity to actually access packaged solutions, maybe buy them as a service out of your operating expense, and get started on your own digital revolution, your own transformation and evolution as you go. Freyer's going to use Industrial Operations X. In fact, they're beginning to use some of the packaged solutions that we've just recently introduced. One of them is our work with Microsoft and OpenAI to bring ChatGPT to our PLCs. Now, that's a whole lot of acronyms. But let's think about the augmented intelligence that is now coming into our private lives. And you've seen all of the worry about what is augmented intelligence going to do. Actually, they call it artificial intelligence, and it sounds really scary, and maybe it is. But if you're going to use these tools, not in a big, open, uncontrolled data set like the entire volumes ever written known to mankind, but instead apply those tools that have been developed over decades to a data, not a data lake, but a data puddle, a puddle of your creation, where you know that the quality of the data in that puddle represents your own operations. Now bring the power of augmented intelligence to play and enable the programming of PLCs. Think about it. This makes every one of us capable of programming the automation. This is no longer out of reach to the people who we're going to need to bring into the workforce. This is the power of the platform. And I mentioned the virtual PLC. Let's take a look at what this is. This is exciting for a couple of reasons. Siemens bringing a software-enabled controller to the table, and not just our hardware, but any hardware. Think about a hardware-agnostic solution, because we know that manufacturing environments everywhere are heterogeneous. Over the decades, we've brought technology from all kinds of suppliers into this working world, and we have these solutions working side by side. And now the virtual PLC enables us to access that hardware through a software interface. Now, why would we want to do this? Well, for a couple of reasons. One, we do want to start thinking about hardware as a service. Of course, right, everyone is into this shared economy. Everyone's into this idea of being able to access remotely. We want to be able to build apps that allow our hardware to do different things. Here's the answer. So Siemens Accelerator offering the new virtual PLC can enable a service technician to be able to get an alert on their iPhone that says, hey, something needs your attention. Be able to see the diagnostics that come through that application interface, and then to be able to take corrective action. Think about what this might do for our workforce management. I don't know about you all, but throughout the pandemic, we had a little bit of a discussion about the haves and the have-nots when it came to flexible workplaces. I'll tell you, our heroes in manufacturing went to work throughout, and they kept our factories up and running. We asked the people who work in offices to make sure that they stayed off the streets and kept our first responders focused on the people who absolutely needed to be out and about. And that flexible work environment question now is kind of central to the way companies work. Well, what if, with a software interface in the future, our factory staff didn't have to be tied to a 3-shift-a-day on site at all times? What if we actually could build workforce flexibility in because we now have the kind of interfaces that are going to make it possible for us to allow the machinery to do the hard work? Now, by the way, Freier's got this concept, and they've got it down cold. What they've realized is that as they go about changing their operations, one of the key questions they want to ask is, what are the dangerous, what are the difficult, what are the hard tasks that we don't want to ask our people to do? Battery recycling. What they're using now is robotic solutions to make sure that as battery packs come in, they can be pulled apart and get made ready for recycling. This is the power of technology. The robots aren't coming to take our jobs. They're coming to take the boring, dirty, dangerous parts of our jobs. And we want to put them to work on exactly those things. OK, so here's where I want to end with all of you. And then we'll open it up for questions. How do we optimize for change? You see, what we've been talking about here is the introduction of technologies. But if you listen closely, what we're really talking about is who are we as people? And how do we operate in this world of incredible opportunity? And the question I've been asking myself, and I hope you'll join me in this quest, is to answer the question, instead of trying to find an optimal state of being, what would it look like if we got our teams to focus on optimizing for being in a state of constant change? Now, here's the way I think about it. You remember back in the day, we'd had a process. I was at IBM, and they'd say, hey, here's the way we've been doing software development. We're going to go through a change management process. We've appointed a change management project manager. This new system is being introduced into our environment. This is going to be uncomfortable, but we know we need to make you comfortable with change. But what we're going to get to is a new future state. And that future state is going to be the bomb. It's going to be everything. This is going to have everything perfect. And all we have to do is go from production process A to production process B. Well, guess what? The world doesn't work that way. In fact, if you've watched, you've seen the Moore's Law affecting our digital worlds. In Moore's Law, change takes place at an exponential rate. And while that has definitely hit our software lives, I believe it's now going to be hitting our industrial lives. And that's a good thing, because think about the possibilities. Think about the possibility of having a state of constant change in your own environment. We know today what demand is, but we don't know what it will be tomorrow. And if today's manufacturing processes require us to plan for products 18 months out, that's actually not going to be satisfactory to customers in our future state. And the technology we have available to us today makes it possible for us to be planning, designing, and making in near real time lot size 1, from mass production to mass customization. And the organizations who successfully go on this journey are going to find themselves in a world that there's unlimited opportunity. And I fear a little bit for those who aren't willing to make the change because I fear they're going to be left behind. But I think we're all here at Automate because we're the ones who are going to drive the change. Let's just pause and think about this for a minute. What's coming? If we're able to put together this the capabilities today of augmented intelligence, with the environments that we have, we can actually build things that folks can't dream of today. If we're able to work together to introduce the industrial metaverse, take a look at BMW or take a look at Freyr with the work they're doing with us and NVIDIA and AWS, we can create an immersive, three-dimensional, photorealistic experience using the world's most comprehensive digital twin provided by Siemens in order to get people connected and working together across geographic boundaries. Now, with additive manufacturing, we can move materials and make things where they're needed. What comes next? We don't know. None of us know. Each of us has a little piece of the puzzle, but none of us can see the big picture. And the greater we dream, no matter how far we dream, I'm convinced we're not dreaming nearly big enough. And I guess this is my last message to you all, because maybe in the past, you would have heard from a Siemens leader who would say, we are the best, and you need to buy our equipment, versus all others. But we recognize that we're not going to be able to have all the answers, and we're not even trying to. What we're trying to do is to be the best partners in an ecosystem where we're developing game-changing solutions. We've got big challenges, folks. Climate change, urbanization, more and more people living in cities, the aging demographics of people everywhere. These global megatrends are inexorable forces that are shaping the world. And it's going to be the manufacturing sector that brings us what we need to overcome, to adapt, to be resilient, and to thrive in the world that's coming. And we're excited to be in this journey with you. Thank you. Well, I hope you enjoyed my talk at the Automate conference. If you have feedback, you can always write to me at optimist.us@siemens.com or find me on LinkedIn or Twitter, and please look for more resources on this topic in the show notes. Thank you for listening. Please follow us on social media and on your favorite podcasting platform. Thank you for tuning in.